This is again a video on information coding, which is basically it is a form. I originally came up with this idea for the purposes of error detection and correction, but it is more ideally suited even for data compression. Most data compression solutions can be used for the purposes of error detection and correction, and likewise most data error detection and correction, which are methods can lead to the discovery of data compression methods. So both of them are very, very closely related. This is a simple form of coding, which is basically even odd coding. Here you have L dash bits numbered from 0, 1, 2, 3 up to L dash minus 1, and this is the length of the information. There are L dash bits and there are R1s in that bit. So what you do is, first you maintain in the first level, it is a form of a tree coding. In the first level you maintain the number of ones in the even location and the number of ones in the odd location. In the next one you maintain within the even location. You split the information into two parts, two streams. All the even locations is one stream, all the odd locations is another stream. So within the even location you maintain the number of ones in the even location, and within the even location you maintain the number of ones in the odd location, and in the odd location too you maintain the number of ones within the odd even location and number of ones in the odd location. Within this even and even you maintain the number of ones in the even location, number of ones in the odd location, number of ones within this even here, and odd here, and even here. Within the odd location again you maintain the number of 1 in the even, and within that odd in the previous one maintain the number of odd locations within that. So you'll have like this, odd here, even. Like this you maintain a tree of information, right? So suppose this tree has to be for a very, very short, small, or a very, very short height h. If h is the height of the tree, so the size of the code will be 2 power h, 2 plus 2 power h, 2 square plus 2 cube plus 2 power h times w, where w is the, right? So let's say the w is 4 bytes or 32 bits, and you maintain a tree of height up to 10 levels. 8 might be sufficient, but you maintain it up to 10. So you'll have this comes out to nothing but 2 power h plus 1 minus 2 times w. So for a 4 bytes, that is 512 megabytes of data, if you maintain a tree of height h, say 10, then the size of the code for the entire 512 megabytes will only be 2 power 11 minus 2 into 32 bits is 4 bytes or 4. This will give you 2 power 13 minus 2 power 3 bytes for 512 megabytes. or around 8 kilo, slightly less than 8 kilobytes, which gives you a very, very high order of compression. So this form of coding, together with others that we have seen, such as, for instance, one is maintaining summation I square, I cube, and up to a certain level, I power x, where x is very, very small. This is one. Another is R, number of R selections, and a table of size 2 power R. All of these come under the category. Another we have seen is where we maintain a base and vary the base. Base for 1 bit, base for 2 bits, base for 3 bits, and so on. And with table of size 2 power 1, 2 power 2, 2 power 3, up to a certain level, and very, very small level, different bases. So the number of values which correspond to each of those digits. So all of these methods together with this one come under the category of what might be called as jigsaw coding, where the code is compact, which uniquely identifies a. In this method, what you do is try to find a distinctive, a unique characteristic of the information, and which can be compactly coded, very, very compactly, but that is sufficient to recover the original larger piece of information back. So this form of coding is the encoding part is slightly easier, but the decoding part, even though it can be done, you can possibly come up with many different efficient ways of coding it. This is actually so this form of coding, they all have one common feature in them, and therefore it might be called as some sort of a jigsaw coding, where the decoding part is a bit like solving a puzzle. So you get the original information, but the code is sufficient to get the entire information or original information back correctly.